Okay, thank you. Welcome to this talk. I will share with you my little expertise regarding a project I did to let's say control my house, my home. It's a project started long ago and finally reached OpenBSD. This is via this project that I meet the OpenBSD, and I will explain all my project. So first of all, my name, Vincent Delft. You see my blog website, my company website, and if you want to reach me, you have my email. So I will explain which component I've used to monitor my home. The lessons learned since 1988, so it's quite a long time. And the problem I had with Linux, because I've started with Linux, and why I choose OpenBSD. And then the next topics are quite recent. If we have time, I will go through them. So first of all, the components and the objective. So it's to monitor my home, my house, and I'm using infrared captors in different rooms. I have the concept of zones, so you can activate a zone and deactivate a zone, like for example the garage. If you have animals, put them in the garage and you activate the rest of the home. I would like to have a system which sends SMS and also receives SMS, so I can activate, deactivate zones by sending SMS from my mobile, and I received events on my GSM too. I have sirens. I have a small web interface when I can look at the log files, some details regarding the different events. And I have webcams. So I would like also to see from any device what's going on around the house. And for sure, I have also an objective to have a cheap solution. Budget is not unlimited. So let me share with you the outcome, and then I will explain how I came to this outcome. So first of all, OpenBSD for me, for this project, was the best system amongst the different I've tested. Very flexible. It runs on very different kind of hardware. I've implemented recently a read-only file system, which is really great. I will explain how I did that and why I did that. The man page, very complete, awesome. Big thanks to the OpenBSD developers. It helped a lot. Having a feature, but explain how to use the feature is really great. The upgrade system, so every 2 years you have a new release. You have a very simple system to upgrade your machine. We have also the syspatch, which allow to keep your machine safe and up to date in terms of security. This upgrade is very straightforward and first time right. You really can apply. It runs. I never had any issue with that. It takes a little bit time, but it's mainly because of my internet connection. It's not linked with the process itself. I've talked about syspatch, and I hear and I read some remarks regarding BSD is dying. It's no more an option for today. Don't listen to those guys. Try OpenBSD yourself. Make your own evaluation of the system. It's really a great system, a great operating system. And at the end, I keep it. It's for me, from my point of view, the best system for this project to monitor my house. So if I go a little bit into the details, at the beginning I was using this card. It's a card from a company called Wellman. It's no more produced. It was in 1998. Basically, I have 16 I/O ports. So on and off, and I connect this card to my system via a parallel port. Then I have a small GSM device to send and receive the SMS. I have a small board. Currently I'm using an Atom board. It's just because of power consumption. It's cheap and low power consumption, so it's perfect for this kind of usage. 4 GB of RAM is far enough, a small CPU, and I'm not using disk for the moment. I will explain why. I'm using a small axis camera. I've bought them on eBay. They are cheap and they are working quite nicely. And for sure, a reliable operating system to make this system running 24 hours a day, 365 days per year, so you have to have something which is reliable. On the software side, I was forced to use the i386 systems until OpenBSD 6.0. I will explain why I've changed. I'm using an HTTPD server for the log file I'm presenting via web interface, also to display the image of the camera. The camera is the axis camera has a motion detector, so it sends a picture when there is something changing in its area, and send those pictures on an FTP, the daemon that runs on the operating system. I need a C compiler and I have a bunch of Python scripts I will explain. So basically I've developed on the Wellman board a C program to loop around the in bay and out bay API and to look at those I/O if they are open or closed. This was easy to develop, very simple to build, and in fact it's a big loop which look at all those I/O and check their status and read them or set them if you want, for example, activate sirens. This was nice, but there is a but, and I will explain a little bit later why I put the but here. There is also another package which allow you to manage the SMS. On OpenBSD, you just have to type package add SMS tools 3, and you have all what you need. There is a configuration file. You just have few parameters to update. The device on which your SMS device is connected, so the serial port. If you want to do incoming, the CS convert is for the character set. Then the initial command, the AT plus CHUP is just to hang up on current connection if there are. And then you have to develop a small event handler, so a small script which will be triggered when the system received an SMS. I will explain that a little bit. So this small program received two parameters. The received, saying that you have received an SMS, and the part where the SMS resides. An example of SMS is this one, so you have a lot of information coming from your providers, and the most important is the last element, so you have the length of the text, blank line, and then the text you have received. In this case, I received an SMS with the word status. If you want to send an SMS, you just have to put a file in this directory, whatever the name. You can choose the name of the file, just put the file there. It will be taken by the SMS daemon. You have to respect this template, at least. You can have more elements, but you have to at least respect this. So the destination, which GSM device you would like to reach, a blank line, and then the text. And You have to limit to the 120 character, I think. For the web server, at the beginning I was using a small program called FAPWS, which is a Python, a kind of Python library, which allow me to easily display some elements. I'm now using the HTTPD provided by OpenBSD. It's light. One of the key elements in all this project is to have something which is light, because the board is quite small. But HTTPD is perfect for this, and I'm running it in a shroud environment. So even if someone finds my machine, he cannot break it. This interface does not allow you, for me, to configure the alarm. So security-wise, it's not possible via this HTTPD to break the system. If your provider does not allow you to have a fixed IP address, you have to make a solution with dynamic DNS, like, for example, FreeDNS. You have to install a small script, for example, every 5 minutes, which will update the FreeDNS website concerning your IP address, so you can always reach your web interface. Oops. So for the camera, it's just a normal situation. You just have to configure the camera that they send a picture to your FTP server. So you just have to provide the IP address. You just have to also provide the user ID that the camera can use to put those files on your OpenBSD machine. So a couple of commands. Like I've presented there. You can have multiple cameras. I have 2 cameras, but you can have as many as you want. So my lessons learned since 1988. The time I spent before each upgrade should not be underestimated. In fact, it's one of the biggest pain in this system. You always have a package which upgrades and break your system, a library which change its position, it's no more in the same place. I had a few problems with the board after 6-7 years. So such kind of cheap machine running 24 a day, a full year. Voilà, it's not perfect, it's not ideal, so be prepared to replace the board every 6-7 years. The weakness part in this system is the power supply. So the small device will transform your current in 5 volt, 3 volt, something like that. This element is very weak, maybe because the boards are cheap. And this weakness is most probably the consequence of the other element. I don't know, maybe it's specific to me, but I still have a lot of power cut, a storm, technician on the streets doing stuff, and they interrupt the power for few seconds, 1 minute, but it's enough to kill the machine, except you have an UPS. I had an UPS in the beginning, but I removed it. So every small power cut kill the machine, and then the machine reboots immediately when the power back, and maybe this affects the power supply. Every 2 years I have to replace the power supply. Then you have also the infrared captors. It's also an element to look at carefully, because you have to clean them at least 1 year once a year you have to perform a good cleaning. And in the big loop I've explained, to capture the I/O of the different captors, you have to be smart enough and take into account the false alarm. This is a quite difficult element because you have maybe animals which trigger a captor and you don't want to generate an alarm and activate the sirens. Maybe you have some small insects. Also, if your captor is pointing to a radiator, the fact that the radiator starts, it could also trigger the captor and generate false alarm. So the loop must be clever enough to avoid such kind of alarms. In the beginning, my neighbors were quite annoyed by the sirens which start in the middle of the night, and always when I was on holidays, so quite difficult. So this is why do not forget to have the possibility to manage your system from remote. Having SSH, it's the best option. Via a smartphone, you have application you can connect to your machine and you can manage it directly from the mobile. Or via SMS, you can send SMS command to restart the process, to reboot the machine, to whatever you want. Generate, exclude a zone, for example, from the monitoring. And also an observation, it's not always a good idea to use old machine for such kind of system. Old machine will use old technology which consume a little bit more power than the new one. So if you want to keep your electricity bill low, it's better to buy new boards like the Atom, for example, which is optimized in terms of power consumption. So my story is this one. At the beginning, I started with Slackware for about 4 years, so as from 1988. At that time, I was playing with such kind of device. It was a pain to install Linux, about 20 disks to install the Linux system, but it was working quite well, quite reliable, and upgrade at that time, upgrade of Slackware was a little bit difficult and required lot of effort. So I migrate to Red Hat. I keep it about 3 years. But then I had also some difficulties with the package and the RPM package, which generates some situation where I'm forced to update my programs. The library moved from one place to another one. It was not perfect. So it is in the time of 2000, so maybe they have found solution today. And then I've used Gen 2, which was for me one of the best system. So quite reliable, upgrade not so difficult, quite predictable. The biggest problem was that you have to build from source. And this board was the only one with the i386. So when you have to upgrade, it takes 1 day. But it runs quite nicely. I also observed that during this about 10 years, I had 2 disk crash 2 times. I don't know. I've never understood why. Maybe the manufacturer of the disk is not good enough at that time. I don't know. It's just an observation. Then in 2009, there is a small gap of 2 years if you look carefully, but in 2009 I've tried the OpenBSD. It was quite easy to install. The upgrades are fantastic, really easy. All the features, there is no so much variation within the system. When you have a feature, it stays more or less always. It stays as it is. Small upgrades, small add-ons in terms of feature, but the main aspect remains. So for such kind of project, this is really, really great. OpenBSD is secure by default, and as I said, the manage page is very, very useful. So it was kind of an ideal situation, but in 2013, I see in the mailing list that it was said that the IO perm in B, out B that I was using was not foreseen to be implemented on the 64-bit system. So I'm say, okay, I have to continue with the 32-bit. But then in 2016, they decide to remove that also. So OpenBSD 6.0 was a decision for me to move away from this old board and to buy a new one. So since I do not have anymore the possibility to interact with my board via this API in B out B, I was forced to buy a new one. I bought this from a vendor called Denkovi. It's a very small board. If you look at the size of the internet port, it's very small, and I have 24 I/O on this system. It's not. The cost is quite acceptable, and I've used this system, but not directly. So I'm using what we call optocoupler. It's a small device which allows you to connect a system like sirens, like infrared captors. And if you have an electrical problem on this device, it will not break the board. It will break the optocoupler. So it's a kind of protection, electrical protection for the board. So I've built a new loop. I did it in Python to look at all those ports, all those I/Os via SNMP get command, and you can interact with the board via SNMP set command. So it's quite really simple to implement. The same logic to avoid the false alarm. So quite simple. The SMS tools is the same. FTP daemon is the same. HTTP daemon is the same. So really, one component of the solution was rebuilt. And now, to tackle the system, the problematic regarding the power cut and the possibility that when the machine boots automatically when the power is back, is that you have a file system check. And in some cases, this file system check asks you question, which is a problem for such kind of machines. The only possibility is to have a direct connection to the machine to answer the question. So my idea was to remove the write option on the disk. So build a system read-only. There is a very good project called FlashRD, which tackles this problematic. But instead of using FlashRD, I've built it myself. And to build, to build such kind of system with OpenBSD is quite simple, in fact. What I did a normal installation. So you start your BSD RD, so the process which allow you to install OpenBSD. I plugged in an USB stick, and I ask OpenBSD to install everything on this USB drive under the same folder, under the same file system. So everything is installed under slash. So I skip the recommendation, the default provided by OpenBSD. Then once the installation is performed, I boot from this USB drive and I change the FSTab like this. I don't know why the color. So what I change the parameter which says that this file system is read-only. The rest remain the same. And I had 3 lines for var/var/def/tmp. So there will be a memory file system, so MFS. I provide a link to a folder where the system can find the different files, and I allocate a certain amount of memory for this file system. So the file system will become read-write, but in memory. There is no link with your disk. So then you have to provide information in those 2 folders. So just copy what you have in /var into the new folder. The same for def, and for tmp I don't need files. So it means that when the machine will boot, those /var and /def will be seen by the kernel as normal file system, but they are in memory with the information you can find is cfg/var. So very simple to set up. The only recommendation I have is just to have at least 4 GB of RAM for this. I'm able to boot from USB 2 port on lot of different board. I don't know why for USB 3 it doesn't boot. Maybe it's my fault. I don't know why OpenBSD is not booting from those USB. I have to check that. So there are few elements to take into account. If you want to make some changes on your system, you have to put back the system read-write via the mount command. Then you do your change, and then you put back in read-only via a mount -UR. If you would like to add some files, for example, via the pkg add command, then you have to update your /cfg folder. I'm doing it via rsync. You can do what you want. And if you want to keep your log files, maybe you have to execute this command once every hour, if you want, every day. For my home, for this project, I'm just doing a sync every day. And for the rest, OpenBSD sees the different folders exactly like a normal OpenBSD system. So it's quite easy. And via this system, you can really shut down the machine. You can kill it. You can plug out the power cable. The machine will go down. You plugged in. If you have configured the BIOS, it will boot up immediately. No file system check, nothing. It just boots normally. So for me, it's really the perfect situation. And for sure, I have a disk attached to the board where I put the picture from the camera. And for this system, okay, I could have issues when the machine boots. I could have file system issues, but okay, it's just the picture from the camera. I prefer to have that damage, and my house is still monitored and controlled. And I'm using this system since about 3 years. Without any problem anymore. An observation, since 2009 I'm using OpenBSD, so I never had a disk crash. Why? No idea. Maybe the manufacturer are doing better disk now. maybe it's coming from OpenBSD, no idea. It's just an observation. And the future idea is to have some power over Ethernet devices, so my different camera will have just one cables. Today they have two, one for the power, one for the network. So this will facilitate the possibilities and the setup of the camera. So voila, this is the conclusion. This is the same slide I showed before. So for me, OpenBSD is by far the best system for this project. It's really simple, light. It can run on many different boards. Easy to tune, easy to adapt, easy to upgrade, which was one of the pain. And it's secure by default, so for such kind of project, this is really a good feature. Voila, and that's it. So if you have questions. Yes?
Two questions. One, had you heard of OpenBSD before you tried it, like when you were doing Red Hat and stuff like that? Had you heard about, did you know about OpenBSD then?
Before.
Just repeat the question before.
Okay.
Because the people on the.
Okay, so the question is, did I heard about OpenBSD before this project? Yes, I heard about OpenBSD. I was aware it's a system existing since long ago, but I never tried it before. So this project was a trigger for me to have a look at OpenBSD, and when I tried to configure and to set up it for this, I was amazed how simple it is. So now I'm using OpenBSD for a NAS, for laptops. At home, all machines are OpenBSD. My kids are using OpenBSD. It's just my wife is stay with Linux, but all the rest are OpenBSD. And the second question?
You answered it. I was going to ask, how did you, what made you try?
No, it's honestly, if you want to make your own judgment, your own evaluation, try it. It's the best thing you have to do. It's quite simple. Just use an old machine and perform the standard installation. The standard installation will use the whole disk, so don't imagine to have dual boot at the beginning. You can, but it requires a little bit of configuration aspect. But if you want to keep it simple, dedicate a disk, do your installation, and then you have the package add command. You can add what you want. It's very simple. Other question? Yes?
I wanted to ask if your SNMP board also supports track events instead of
Yes.
calling it. Have you investigated instead of evaluating the SNMP traps instead if you receive an event?
Yes. So the SNMP trap exists. Oh, sorry. Just. So the question is, am I using the SNMP trap feature on the small Denkovi board? I've looked at it. The problem is that you receive different kind of message, more than what I expect. So you have to filter them. And I was a little bit surprised that some events have a small delay. And this is a problem for me. As I explained, I have to be quite smart to detect the false alarm. And the time is really a key element. For example, if I have an alarm on one captor and let's say within 10 seconds another event on another device, it means that someone is walking inside the house. This is not a false alarm. If I have one signal and then 15 seconds, for example, and another signal, it's something like a false alarm. So the timing is quite important. SNMP trap was not the best way to have such control on the timing. So I prefer to poll them manually, within the loop. Other question? Did I convince someone to give a try to OpenBSD? It's a question?
Yeah. So you talked about all the work, software side that you did. Is it something that you have available quickly, or do you think it's simple enough that it's not really useful to share it? Or?
Yes, I'm not a developer, so yes, I can share it, but I don't know. Yes, sorry, I repeat the question. Does the code I did is available somewhere? The answer is no. Maybe I could, but I'm not a developer, so it's not clean for sure. But maybe someone else can improve it. So yes, I could do it. I don't know if there are other persons interested in such kind of project. No idea. But why not? I could think about that, and maybe in the future I can push the code on a GitHub repository.
CVS, surely.
I'm not a developer, so I'm not using CVS.
Do you still have happy neighbors?
Yes, they are much more happy now. The 3 first year was a little bit difficult with them. Now they are much happy. The logic is much better. Okay, thank you.